Okay, so this should be working properly, and this is going to be lecture 4, so week 4 right here that I'm highlighting of the ME 228 coursework. So the reason I'm posting this lecture instead of actually giving it in lab is the career fair is on Thursday, I believe from like 11 to 5 or something, which kind of coincides with some of your lab sessions. And I want to give you guys the flexibility to be able to go during lab or have more freedom of the day to prepare for the career fair because this is important and you should network. Even if you don't get an internship, you should go make yourself known because this is the kind of thing that will eventually get you a job. So the couple things that we're going to be going over is announcements. We're going to be talking about a little bit of workbook stuff. I will be going over isometric and orthographic views again. We will be doing discussing 3D printing, both the homework and the methods that you'll need to use with 3D printing, things that are expected, things that are not expected. And then I will be teaching you guys drawing files and my expectation with those drawing files and show you how to do it. I will start with SolidWorks when I do the drawing files. So Inventor people, you'll watch up and through the 3D printing and then skip to the time that the announcement I send out will say. Or you could just watch the whole thing. I don't really care. After that, sometime sporadically listed throughout this recording, I will type out the password for the quiz that you're going to take. It's 10 points. It's twice the amount of points that is usually the quiz points, which will cover both last week's content and then a couple things that are in this week's content, but it should be pretty easy. You guys shouldn't have too many issues with that. So let's just launch right into it. One thing I want to explicitly outline is that the career fair is not mandatory, but it's highly encouraged to go. As well, grading sessions are not canceled, so if you have a grading session on Thursday, I'm sorry, you still have to go to that. You're not excused from that. So hopefully everyone was having a good time with parametric constraints and relations. From last week. That shouldn't have been too challenging for you guys. I kind of gave you a really solid introduction to that. So if you still have questions, email me and I'll do my best to answer them. As for the workbook stuff, so basically what you guys are doing is previously you guys were learning to take an isometric view and change it into an orthographic view. Now, this time, so that was for week 3. Now, for week 4, this week, we are doing the exact opposite. We're going to take an orthographic view and change that into an isometric view, in essence. There might be a couple little additional picky content things that the book may talk about. Make sure you are reading the workbook and understand it. But for the most part, I believe that this is simply just learning how to translate these kinds of views. So before I started this recording, I'm just going to be paranoid and check that it's recording. Okay, I think it is. Let's double check. Okay. So with this, right before I did this recording, I drew this orthographic view of a part. And so hopefully, if we have learned week 3 properly, we should be able to do the opposite. And instead of taking an isometric view and making it orthographic, we're going to take an orthographic view and make a 3D depiction of it, which is very similar to what you guys did in the week 3 assignment with coming up with those orthographic views and then making them in SolidWorks. So how you approach this is pretty much the opposite of it's just backwards. So what you usually want to do when you're drawing these, so I'm actually going to use a thick pencil. So sorry if the lines are kind of jagged and icky. I'm doing this over a mouse, so it's a little hard. But what you do is instead of looking for the front face and then adding the top or the right, you're going to do the opposite. So first you're going to be like, okay, so my box is probably going to look like, the box that I'm going to be working in is probably going to look like something like this. Something like this. So the space that I want to work within is this, and so it's the overall like length, height, and width of the stuff. So actually, for us, it would actually probably look more like this. And then let's get an eraser. This is harder than I thought it would be. All right, here we go. Because if you notice, what we would consider the front view is long, and the top view, it looks rectangular but horizontally rectangular, and the right view is kind of skinny. So that's kind of what it would operate with. And so when we are drawing this stuff, we know that this is going to be the front view, this is going to be the right view, and this is going to be the top view with our isometric sketch. And so this is kind of like the corner. This is the corner, and the corner that we're looking at. Never ignore those corners. I know it's easy to ignore when you do these workbooks. So with the front, right, and top view, we know that it's going to extend all the way along the side here. We know that in the right view it's going to extend all the way along the side here. And at the edge of the right view, it seems to me as if in this corner it does not extend all the way up, but it does extend all the way up on this corner. So I'm going to draw this, and it looks like it's a straight line. So with this, I actually did mess this up, so go away. Yeah, that should be fine. I also forgot hidden lines on this because I got lazy because I was trying to figure out. I'll add the hidden lines just for the sake of clarity. So hidden lines. And I guess we could add this line. I don't know, that's a method of interpretation. You can get mad at me later. And I'm not bothering to add a center line. Actually, I will. Just kidding. Center line. So in order to draw this, we know that there's a hole somewhere. This seems as if there's an inclined plane somewhere. So we need to figure out, we have these three baselines, and we need to fill in the rest of it. So we know that, let's say that it goes up to a height of here. This is the corner right here. That's the height it will go to. Usually you'll have this either gridded out or you'll know the dimensions. And so we know that looking between the front view and the right view, that this actually extends all the way out like this and goes back down. Now, something that might be a little bit weird is when you were doing week 3 from isometric view to orthographic view, it was about taking a complicated part and breaking it down into smaller 2D depictions. Now you're doing the opposite. Now you're taking smaller 2D depictions and breaking it or melding it back into a complicated 3D view. And when you do that, it means that you are actually going to have to switch between front and right views and front and top views quite a lot. So you can't just go off of the front view when you're drawing this front face. You're going to have to be interacting between the front and the right and the front and the top to make sure that you're doing the correct thing. So we know that the right view goes up at a slant. So it's the nice little slant, and it goes over about halfway to the top view. So we know that all of this has got to be slanty, right? So this will go also at a slant. And we also know that the front view was flat for the rest of it because the front view and the top view have this interaction where it's clearly a flat surface. So you're operating within here. Then you also know that you have a circle cut right here, and then you're done. So basically that is how you translate it in between. And because this is recorded, I know I'm moving a little bit fast and people may have questions. Feel free to email me about this stuff. This is specifically the kind of stuff that you have to be able to do yourself. There's not really a cookbook instruction list to how to do this for every specific situation. So I would recommend that either practice or replaying what I just did kind of gives you a sense of what is happening, and then it will slowly come to you in time. Knowing how to build this is something that you'll have to know how to do for the midterm, so it's something that you should take seriously and is pretty important. So that's just the thing I wanted to talk about with the workbooks. So let's go to the homework and check out what is expected for week 4. let's see. So this is blah, 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 drawing stuff, drawing stuff. Yeah, so for here in part D, these isometric sketches are you taking orthographic views and changing them into isometric views. And I'll talk about the drawing stuff in a little bit. So if we go back to this homework thing, let's talk about grading for homework 10 and 3D printing and all that stuff, because you guys are pretty much at the point where you're going to have to know how to do that. So I have posted the homework 10 right here. It's lovely. It's even got a little exclamation point. And there are two things associated with it. So I'm going to go over this homework 10 assignment because I want you guys to be able to understand the parameters of the homework and know that, like, as of this moment, I have assigned homework 10. So if your name is on the schedule, which I'll talk about later, you may have to worry about this quicker than on week 10 or past that. You may have to worry about it within 3 weeks because all of you have the skills to be able to do homework 10 as of this moment. So this is the assignment 10. Using a 3D printer, you can earn 30 points total for this assignment, but you can also earn an extra 5 extra credit points if you turn it in early. So keep that in mind. So essentially the instructions are, you in SolidWorks or Autodesk, you need to make a unique part that you want to print. I don't care what it is. I don't care what it looks like. Just something. The parameters within this, it has to not be built crappy. That's what show appropriate geometry means. So basically, don't make something that's not physically possible for the 3D printer to print, because then it won't print it and it will get upset, and then we will get upset. This is a big one. Use no more than 8 cubic inches of material in its solid state. So volumetrically, if your part makes up 8 inches of cubic material or more, then you will not have your part approved. So the reason I'm saying this is because I used to be like, okay, well, your part needs to be like a 3 by 3 by 3, something like this. The problem is this can take many forms. It could be something that's really long and flat, right? It shouldn't be this simple, by the way. It won't be approved if it's this simple. Or something that's like kind of like extended out on the sides. Like this all could be the same thing, right? Because this is just a solid block, but depending on the thinness of your walls, that could look like many different things. So what ended up happening is there was a lot of confusion and a lot of creativity was inhibited. So instead, I'm doing volume based cubic inches of material, and I will show you how to calculate that in a couple seconds or minutes. Yeah, we don't care what it is as long as it follows the other rules. After you make this in SolidWorks or Inventor, you need to get your part approved by Onmish and have him sign the permission slip. This is mandatory. The 3D printing authorization form, so that permission slip is literally right here. So you can print this out and bring it to Onmish during his office hours, which is posted below. Then you'll convert the part to an STL file, which is really easy to do, and the instructions I go over will show you how to do that. You physically 3D print the part. Then you submit the part file and STL file into this homework 10 submission right here. You would upload the files right here, and whoops, that's not it. And then you would physically go into lab on your due date because it's due during lab, and then you would hand me the permission slip and show me the form. Now, let's talk about additional considerations. There's 100 of you. It takes forever to 3D print depending on your design. Sometimes it takes an hour, sometimes it takes 15 hours. So it's really hard to make this do all at the same time, because if you all printed consecutively, it would be 17 consecutive days of printing. So there's no way I can make this do at the same time, because how am I supposed to expect you to plan 18 days in advance, to sign up for your time? It's stressful, the printer would run out of material, and I just don't want to deal with it. So we're going to be staggering the due date through a randomized list of students, which is on the 3rd page of this assignment. Now, the first due date is going to be due the week after the first midterm on March 9th, which, Thursday, March 9th, right here. The schedule is put below. If you turn it in at least a week early, I will give you 5 extra credit points. So usually what happens is the big rush to get it done happens at the end or when projects are due. So if you do it in one of those off times really early, because some people are really gung-ho and love this project, then you get an extra 5 points of credit that will all count towards your homework stuff. So you could get a 35 out of 30. If you have questions about 3D printing, please don't contact me. OnMesh is the TA that is required for it. If OnMesh doesn't know the answer, then he will forward it to me so that I can handle it. OnMesh has done this last semester. He's a very knowledgeable dude. He's really, really nice. He has office hours on Tuesdays from 11 a.m. to 1 p.m. in Learned 1100 right next to the 3D printer. So you can email him with your questions if you can't make those times. Remember, if you do not get your part approved by OnMesh, you will not be able to turn in the rest of your stuff. So if you go ahead and 3D print your stuff and it's amazing and you didn't get your approval form signed off by OnMesh, then you will get a 0 for everything and not be allowed to use the 3D printer. So we're taking this very seriously. So I even added FAQs. So it's going to be hopefully answering some of the questions you may have regarding this. How do I use the 3D printer? I'll be talking about that in a second. What if the 3D printer is being used when I want to use it? There is a sign-up sheet currently in Learned 1100 that covers the entirety of the semester from 6 in the morning or like 4 in the morning, something stupid early, to midnight by 2-hour slots. So you should be having your part conceptualized and made. You go into Learned 1100, you sign up for a slot, you show up for that slot, and then you have your 3D part be printed. Now, if you just put in your name and you don't add in contact information or anything or purpose, then that slot is considered forfeit. So if someone invades your slot and you didn't fill out the sheet entirely, then sorry, that doesn't count. The reason is if you conveniently forget to leave your cell phone number and then you don't show up at your specific time or your part runs extra late, then the other kids that have already signed up for the schedule that you aren't adhering to can call you to ask what's up. Also, a lot of students will pull that whole laundry in the dorm thing where they forget that the 3D printer is in the 3D printer. And so students should be able to text you or call you to ask permission to move your stuff. So this is something you need to be able to do. Now, when your 3D printer is out of material, when you see that sheet, you need to be able to tell me, OnMesh, Professor D'Agostino, or Al Saivangse, any one of us needs to know if the 3D printer is a quarter tank or less, because if we don't, then we can't replace it in time, and then someone gets screwed because their stuff isn't in it's not, they're not going to be able to print because we didn't have time to change the cartridge. Also, something to keep in mind, I'm even going to make a new file and write super big and make it huge, so guys who are not even listening but just kind of watching it can see. If the 3D printer is less than a quarter to an eighth, I don't know if I spelled that right, full, then your part will come out looking like crap. Now, I mean this. I seriously mean this. If you have a full cartridge, the cartridge will print wonderfully. If the cartridge is empty, then that means there's going to be air pockets influencing where the material is distributed on your part, and you're going to get a really crappy, ugly looking part that doesn't look anything like you had. So please do that. I don't care what you print. Your due date is put on the next page. You forgot that it was a thing because you didn't listen to this lecture and or totally just forgot, and you do not get an extension no matter what. So you can recoup 10 out of 30 points by actually making it, but you won't be able to turn in a 3D printed part. Yeah, and still remember, check with OnMesh, because if you don't get your approval permission form done, then you will not be able to do this. You're not going to be able to turn it in. Here's all the names of all of y'all and when it's due, so you guys can check that out. Now, you're probably thinking, oh my gosh, Melanie, I don't even know how to 3D print. Why are you assigning this? Well, under course documents, there is a file, 3D printing instructions, that if you pull up, OnMesh has actually edited it. It was terrible looking last semester because it didn't have pictures, which confused students, but the instructions were really good, so we just kind of added instructions and kind of did troubleshooting. So this is basically how you 3D print. Now, 3D printing is not hard, all of you. Using the 3D printer that we have allocated for you is actually quite easy. We bought it because it's essentially a plug and play 3D printer where you plug in your model, you upload your model into the software, then you 3D print it just like a normal printer essentially. So the hardest part is actually making a design that is feasible, will work, and within the volumetric limits of the cubic inches. So I'm just going to go over the steps on how to do this verbally. You guys can read this yourself. For the record, for those of you that don't know, the 3D printer that is in Learn It 1100 is a big square thing where if you walk into 1100, you hang a left and then hang immediate another left, it's going to be this big square gray box. And it's going to be on a desk next to a computer. So first, you need to create your model, get it approved by OnMesh, and export it as an STL file and save it on a USB drive. So let's assume that you have your model already done. Get it approved by OnMesh. Oh, he added that in. When it's your turn to print, you log into the computer, and then you need to get a platform located into the drawer just below the 3D printer and place it inside the printer. Okay, here's the next thing that actually most of you may not understand because it took me 20 minutes to figure this out. To open the drawer next to the 3D printer, you need to open the small rectangular drawer in the middle first. So what I mean by that, let's see, so let's say that the desk looks like this. So here's a 3D printer and here's the desk, and you need to get into this drawer, and here's the computer. There's the computer. You cannot get into that drawer until you open this drawer first, and then this thing will unlock. Otherwise it won't, and you'll be stuck wondering what the heck is going on. So make sure little box, that's where your stuff is going to go in. So with that, the platform is going to look like that. The platform simply snaps in right here over this metal surface, and it's basically a way of creating a clean foundation for your stuff to print on. Then you plug in your USB drive with your STL file. You open the Mojo Print Wizard and open the STL file in it. So then there's a couple different parameters. So they uploaded a little man thing right here. And so what pops up is a couple different buttons that you can pick. First, you select the surround. You always want to click the smart version of the surround. So basically what it's doing is if you print something complicated with thin walls or complicated aspects of the part, when it's hot, it's kind of unstable. So it adds a support material in addition to the material of the 3D printer that will support it and make it adhere to its shape until the 3D printing is done, and then you either break off the support material or you dissolve it. So it's a way of further reinforcing it, kind of like scaffolding. So you need to select Smart because Smart uses the least amount of support material and it's the cheapest for us to use. You should only be doing this if you're doing it for research, which you guys are not. This is also important. So you see this part interior. There's a difference between solid part interior and sparse low density. So basically, instead of it being a completely solid part, on the inside, it's going to have striations and use less material, which means more people can print per cartridge. Oh, he did a picture right here. So instead of it being filled in, you need to switch it to low density. Then you can select the orientation of your model. So if you wanted to print this man, you could do it on all kinds of sides. Now, with the orientation of the model, the 3D printer likes when you start flat and don't have things that are very high. So the 3D printer with this Mojo Man, most likely the most efficient print would probably, like the fastest print would probably be right here with it lying on his back, because there's not a whole lot of height there. So the 3D printer can print faster and it's probably less likely to be warped. So that's something that you guys should take into consideration. And once you've set all these parameters, you can select the print option. So then it will export it right here. There will be a little bar. And then once it's uploaded it into the wizard, you can open the Mojo control panel. So basically the wizard is like print preview. And then once you've authorized the print preview, you open the Mojo control panel to actually physically print it. Then unexciting things will happen because you will close the door. Make sure the door is closed, by the way, to the 3D printer. And then nothing will happen and it won't be very exciting because the 3D printer needs to warm up and kind of calibrate itself and get ready. And if you're patient and you wait about 10 minutes, then it will light up blue inside and start 3D printing. Needless to say, if it's 3D printing, do not open the door, please. Just leave the part in peace. Do not break the 3D printer. Just leave it alone. And then 6 hours later, in between this gap, once the printing is done, you need to clean the printer, which is basically there's going to be white crap all up in here. So you need to empty that out and make sure you take off the platform. To clean the 3D printed part, you're going to crack off the build platform. And then when he's talking about the wave wash in number 14, basically we have these devices that is essentially rotating water that lets you put some acidic powder in it so it will dissolve the support material. When you fill the wave wash chamber with water, you need to drop the powder, which is the acidic material, into the wave wash, and then you basically chill for like 3 or 4 hours depending on how much support material you have, and then your part will be washed and you'll be good to go. Now, with this, make sure that you're wearing gloves when you handle this acidic material. Don't be like, don't be like, oh, well, whatever, it's just acidic, I don't really care. It seriously will irritate your hands. So I don't want anybody to be responsible for like acid burns or anything from this powder, because it really isn't messing around. So if you guys have any questions, make sure you email me or Onmesh. I tried to add as much information as possible, so this shouldn't be too rough. So if you have questions, I guess send us emails, but otherwise it's assigned. So the first group of kids are you guys. Sorry, you guys right here. And it's going to be due March 9th, which is in 1, 2, 3, 4 weeks. So you have 4 weeks to get this done for the people who drew the short straw. So really it's not that much time, but you will have to make the decision about whether you want to do homework 10, quote unquote, in advance versus just not worrying about it. Okay, so all right, done with that. All right, so let's get to the homework assignment. So assignment 4 for next week talks about drawings. So so far what you guys have worked with are part files, which a part file is a 3D construct in your solid modeling software programs. A part file or a drawing file is a file that if you export a part file to a drawing file to show a drafting representation of what it looks like. So for now, Inventor people, I'm going to start showing this in SolidWorks so you can drag it forward until you see Inventor to switch to the stuff that's relevant to you. For SolidWorks people, what I'm going to do is I'm going to create a part, I'm going to save a part, and then I'm going to export that part to a drawing file and show you what my expectations are of said thing. So essentially from now on, if you make a part, you will be expected starting this week to export it to a drawing file and format it in a drawing file instead of a part file. So your TA may check your part file, but they also may check just your drawing file. It kind of depends on the quality of CAD. So we're going to start a new file. See, remember that drawing thing that we've been ignoring? That part comes later. All right, so let's see if my computer wants to work. There it is. Okay, so let's make something that kind of has it all. Why not? So when we sketch, we're going to sketch starting from the front plane. And let's make something that looks like, let's make a rectangle, and then maybe another rectangle. Smart dimension this to be 2.5. Smart dimension this to be 2. This will be a length of 2. This will be a length of 5. Let's make it that. And then let's say that we want rectangular cut here. So we're going to smart dimension this to be 0.75. This side and this side I'm going to be set to equal. And I'm also going to dimension where it exists in space, right? So 0.75. I don't know, I'm just making up stuff. You can make up whatever you want. Cool. Also, so it's all black. Black is wonderful. This is what we want. We don't want blue. It says fully defined. So then I'm going to press features and extrude. So then I'm going to select the contours that I want to extrude, or select the shapes, and I'm going to extrude it out. I don't know, 4. Yeah, sure. Why not? That looks nice. And then I think what I'm going to do is I'm going to select this surface, and then I'm going to sketch a circle on top of this surface. It seems sideways because I'm not bothering to show the top face. So if that bothers you, then you can change it to the top view. This isn't stuff I anticipate, like, whoops. Okay, awesome. And then we will do an extruded cut. Yeah. Should I teach you guys how to do Hole Wizard? Hold up. Nah, you guys don't need to know how to use Hole Wizard yet. So yeah, we have a circle and a square cut. And then for one last thing, for those of you that didn't learn how to use fillet, the book asks you to select a surface and a surface and then select fillet. I'm honestly not a huge fan, excuse me, of that approach because I think it's kind of allows for ambiguity. So we're going to fillet, let's say, these edges right here. So what I do is I hold down Control and I select the edges here. We're going to fillet the edges to be a radius of maybe 0.25. And then see if something, yeah, and then we'll fillet that, and that looks nice. So selecting the edges is better than selecting both faces when you decide to fillet. So just keep that in mind. So here's our part. It's a nice part. It's all right. And so what we'll do is we'll export this to a drawing file. So first thing you have to do when you finish it is you have to save. So I'm going to save this as SLD Part 1 for SolidWorks Part 1. And notice that the part I'm saving it as is .prt or .solid part. So that's something that you have to keep in mind, is that a part file is in obviously .part or solid part. Now we have a nice fancy way of essentially making a drawing from a part directly. So you could press make drawing from part. You could also just press new drawing, and then you now have opened a drawing file, and so you can select whatever template that you want to use. It might ask for a KU template. Just ignore it. I don't like it, so we're going to use this one anyway. So as you can see, this kind of looks like drafting paper. It looks pretty fancy, and so what it first asks you to do is import whatever part that you want to use. So since there's only one part in my downloads file, it prompts it to be immediately that. So I'm gonna take this and then, yeah, double click on that, and then suddenly this thing pops up right here, the square. I didn't have to click or anything. And so what happens is it now wants to add in your orthographic views. For me personally, this is kind of big for me to fit 3 views on this page. So I'm actually going to use a custom scale and do maybe, I 1 to 4 isn't really, maybe we'll have to make do with 1 to 4. Fine, we'll do a 1 to 4 ratio for now. So what we do is we click and it will add our front view. Then we will trace up and click once to add our top view, trace to the side to add our right view, and then we'll go diagonally just somewhere here to add our isometric view. And then I'm going to press OK. Now, if you notice, as I change where the front view exists, it will change the alignment because everything needs to be aligned for these drawing views to work. Maybe I will do a 1 to 2 ratio. Yeah, I can fit that. That'll work. Fine, that'll work. All right. So what we have here, the isometric view doesn't apply to this rule, by the way. It kind of does what it wants because this is mostly for like to get an idea of what it looks like. So you always have 3 orthographic views and then an isometric view to kind of garnish the thing. Now, if I asked you in class what is missing from this, I would probably get some silence and then people would mutter hidden lines, which is correct. So SolidWorks does not default the hidden lines. So if you select a view, it will be highlighted in orange. There's a display style down here, right here, where you can display how all these things look like. For this case, we want to do hidden lines. So then it adds where the holes are right here in each of the views in an appropriate way. Now, isometric views do never have hidden lines. That is just really bad industry standard. Like if an industry decides to use that, that's their business. But for now, I'm going to teach you guys don't have hidden lines on isometric views in your drafting. So what happens is because this was the parent, this was the first click that we started at, and everything else was based off of this, it will always change the parameters. So what you do is you simply click on the isometric view and change it back. Because this is a child of this parent. What else is missing? And then everyone would be extra quiet and maybe no one would say anything. But we're also missing center lines, right? In our circle cuts. We don't need a center line in our square cuts because the square is not a circle. Duh. So to add a center line, what you do is you press the button that says center line up here. You select one side of the hole. You select the other side of the hole and it adds a center line. And they use kind of fancy centering techniques, so like if it's not centered in the middle, that's also fine. The center line is kind of a continuous thing, especially if your drawing is rather large. Okay, awesome. So this is essentially the bare bones of what we would expect with a drawing view. Now, depending on what the assignment asks you to do, yeah, so it says make a drawing. Yeah. What the assignment asks you to do, you need to label overall dimensions only or all of the dimensions. Now, if you don't read this properly, you're going to have to do all of the dimensions. So let me super clarify this. You should always fully dimension this drawing view. However, if the instructions explicitly tell you not to dimension it, we're just trying to save you time. That's not the proper way to do it. So just remember that. See, it says under defined right here. So you just click Smart Dimension and you start adding stuff in. So you can do overall height, length and width. You can add all these things in that we would expect you to do. Yeah, something like this. Obviously, I'm putting them in ugly locations. One thing about this is presentation is key. So if you are, if this looks ugly, if things intersect, then you're doing it wrong. Because the whole point of these drawings is that they look nice because they are a good representation of the CAD work that you have been doing. So make sure that you add dimensions until this says fully defined. So for this assignment 4, if you go to the homework section, they have files attached to here that is the U bracket. So what you do is you download this, you change it a little bit, and then you export it to a drawing file. And in part B, and C, you need to make these things and export them into a drawing file. So make sure that you are doing everything properly and reading the full paragraph, because that could be something that may be bad, I guess. I guess now is the time that I will sporadically add the password. Password for the quiz 3? 3? I think it's number 3. Whatever the latest quiz is, it'll be posted at 4 o'clock. Oh, so in 3 minutes. Is going to be random guess. That is what the password is. So for you inventor people, like it's right before you guys start, and for your SolidWorks, it's right after you started. So hopefully you'll be able to do that. I'll probably, like, when Inventor pops up, I'll be like, oh guys, by the way, look at the end of the SolidWorks lecture for that. So I'm leaving this posted for a couple more seconds, and then it's going away. Delete. Okay, awesome. So for Autodesk Inventor people, I'm going to make a new file, and I might make the same thing, I might not, I don't know, whatever. We are going to create a part file and then export it to a drawing file, which is essentially the representation, the drafting, fancy drafting representation of a part file. So this is something that, like, you would give to your boss. So for this assignment 4, the first 3 things will cover part file or part to drawing files, and this is just the isometric stuff. Okay, so we're going to exit out of SolidWorks at this point. There we go. So Inventor's taking its sweet old time. Just like SolidWorks. They're really not that different. Okay, so I'm going to start a 2D sketch, and I am going to make... It's pretty laggy. I'm gonna make a thing. We like things, right? Yeah, that's nice. Yeah, let's do that. And then another circle right here. And then we'll add some dimensions. Whoops, there we go. Let's say 1. Let's say 0.5. And this can be 0.25. That's nice. And then so we'll 3D model and extrude that, and I will select the contours that I want to extrude. So this, no. Extruded cut. Cancel. Why isn't it letting me cut? That's super weird. There we go. Oh, this must not be attached. Oh, my constraints are messed up. Oh well, too bad. I don't want to waste your time by fixing it. So we press OK, and we have a half circle, which is fine. So then we will select here, and let's make another 2D sketch right here. And I'm going to make a circle cut right here, and a rectangle cut. Whoop, that's not a rectangle. Rectangle cut right here. And remember, we got to fully dimension this stuff. I know it sucks. Between this point and this point, we have to define the... Oh, my dimension came off. Select this point. Select this edge. 0.175. This point. This edge. 0.4. I don't know. I'm just making stuff up. So we've got to fully define it, even if it's tedious, right? Good habits, all. Yes? Okay, cool, awesome. And then we're going to extruded cut. There. And so we're going to select these surfaces that we want to cut. I'm not bothering with the inches because I know it's a through cut. Say this is the part we want. It's kind of ugly, like modern art, whatever. It means something. But then we want to show this to our boss with the drafting representation. So this is a part of an assembly that will do lots of wonderful things. So what we do is we go to File, and we need to save our part first and foremost. So we're going to save this as, I'm going to save it in Downloads. I'm going to say Inventor Part 1. So first save your part, make sure that's done. And then you can either open a file, new. You can open a drawing file. So down here, you can either make a standard drawing or an IDW. I prefer IDW because I think that it's the more updated version. It's the file that I'm used to using, but if you want to do a dot drawing, that's fine, whatever. I don't think there's too terribly much of a difference, but for now we're going to do IDW. So then we wait for it to load very patiently. And this pops up. So it looks, one thing that's nice about Inventor is they have a much prettier area down here. So with this, how you do this is first you need to add a view on it, right? So you press base, the first button that you see. So you need to create a base that you're basing all of your drawings off of. So for this one, it automatically, because this is the only part file that I have in the downloads, it detected it, so you could browse for a different part file if you had different ones, and then it would automatically take all the stuff from the part and then export it to a drawing file. So in this case, I want to make my scale a little bit smaller. This is pretty gigantic. Maybe like a 7:1. Are they? Oh, I love Inventor. Okay, so we have these three different views. So make sure that you click the top view, the front view, and the right view. And then you're going to have an isometric view off to the side. And once all that is displayed, you're going to press OK. And then voila. Wonderful. Now Inventor's cool because it automatically adds in the hidden lines and leaves the isometric view without hidden lines. So that's kind of awesome. But there's a couple things that are missing from this drawing. Yes, there are center lines missing and there's center marks missing. So remember, the center mark is where we can see the circle. We want to make sure that it is actually a circle. Same thing with this edge, but it will only add this part because it's not a complete circle. We also want to add center lines, which is here, center line bisector. Basically, this annotate is all adding all the pretty stuff. Place views is where all the views are placed. It's not as obvious in SolidWorks. So with annotate, I have the center line bisector, so you select one side of the line and the other side of the line, and the center line is added, and it's wonderful. You don't add it here, right, because this is a hole cut. That is not a circle. Remember, guys? Cool. I'm just going to take your silence as affirmation. And you also need to dimension the different sides. So each dimension is its own kind of thing. You can format the text to appear to be larger. One thing, did you notice how I added this side and it didn't say, oh my gosh, it's over constrained? That's because the purpose of these dimensions is to annotate like how big things are broken up between three views. So for sometimes the sake of making the view easier to understand, you will add redundant dimensions because it is not integral to the construction of the part. So that's something to keep in mind. However, you do need to have it fully dimensioned. So like any dimension that you see in these assignments, like here, for every dimension you see here, these dimensions all need to be distributed within these three views, wherever they are appropriate. And for example, you also need to make the dimensions pleasing to the eye. So if you put a dimension like this and it intersects with this line, that is a bad dimension because the whole point of adding a drawing is to make this stuff easy to look at, right? And to make it more presentable. So that's the bare bones of how you do drawings. Can't really think of anything else. I guess like make sure you pay attention to these templates. So if you want to add a title, you can add text right here. You just click text and then add text here. Woo. And it will add text. So whatever the title of your thing is, what your name is, that's the name of my computer, so it just defaults to that. When it was made, what the scale is, what the drawing number is, and the assembly. All this stuff can be filled out and will be asked to be filled out in the assignment. So like I told the SolidWorks kids, the U bracket file is already posted in the homework, so make sure you download the correct one, the IPT. And whoa, that's not the homework. And then you need to make these two things and export them to drawings as your assignment 4. So that's essentially the bare bones of drawing. Still do this tutorial chapter 8. If you do not, there will be problems because like I have skipped a lot of the formatting stuff that isn't directly relevant to us, but is still important for you guys to know about if you're interested in formatting or might do things to different standards. So I guess at this point I'm going to stop the recording. If you guys have questions, let me know. Otherwise, I think you guys are pretty much good to go for this week. So.